Hello everyone, my name is Vansh Sharma and I am from BE Software Engineering Department. Here is my ID card. Today I will be explaining the CPU.hdl program which is task 7.3D. So as you can see on the screen, we have the flowchart here, hack CPU flowchart and the CPU.hdl code. Now I will be discussing the code line by line. First we will go to the chip header. You can see the input chips name as INM, instruction, reset. INM is 16-bit, instruction is 16-bit, and then we have reset which is 1-bit. INM is used for input from memory, instruction for taking instructions, and reset for resetting the chip. If reset is 1, then the chip will be resetted. Then we have the output chips, outm 16-bit, writeM, addressM which is 15-bit, and the PC chip which is again 15-bit. WriteM, it is used for writing in the memory. I'll be explaining the flowchart. The diagram shows how the CPU is interconnected with the data and instruction. Explaining the flowchart. The diagram shows how the CPU is interconnected with the data and instruction memories. This shows CPU receives its instruction input from the instruction memory and also accepts the value of data memory register as one of its input is reset input. Okay, the reset input indicated whether to return the CPU to its starting state or whether the restart the CPU operating from start. In context, CPU also contains a number of outputs that are connected to the instruction memory and data memory. As well as you can see these outputs are also here you can see on the flowchart writeM, outM, addressM and PC. Now we see that ALU provides an output that is written to the data memory. In order to do the ALU must specify a few things, first including the data that the CPU will write into the data memory which is being stored in outM, and address of the write operation in the data memory as the output to send the information to the data memory is the PC, which contains the location of the following instructions. The CPU decode and execute that instruction. Yes. Now we can implement the code of CPU. The A and you can see the A and C instructions. The A and C instructions are of the two types of instructions that enter the CPU from the instruction memory, and thus the flowchart is explained. Now we come to the chip file. The NOT gate, as you can see in the first line, the NOT gate is used to determine whether an instruction coming to the CPU from the instruction memory is an A instruction. However, the CPU first decodes the 16-bit instruction into an OP code and 15-bit value. If the OP code is 0, then the instruction is an A instruction, while if the OP code is 1, the instruction is C instruction. However, in the figure of the A register fed by either the instruction input or the ALU output, as you can see, if the instruction is C instruction, it does the computation in the ALU and the ALU output is fed to the A register. Now the mux is used whether instruct or ALU is stored into the register depending on the value ALU to A. Now we have the mux load bit in the A register. That would be if either the A instruction or the ALU output is fed to. On the other hand, if A register is used to store the value that is fed into the A register, it takes in the in input. A register informs the multiplex in form of multiplexer and the output load. A form the OR gate as its input, and now we have A register in form of multiplexer and the output load. A form the OR gate as its input, and mux16 takes the output of A register and the value currently selected in the data memory register in M and generates the value that is currently stored within the register. Now we have the AND. AND gate is used to determine whether the ALU and is loaded into the D register, and D register is then implemented to load and store the value of the D register from the ALU. This will choose which one to the output, either A or M will be fed into the ALU depending on the 12-bit instruction of the value. Therefore, we have come to the ALU part. The value that is stored in the A register and the value of either A or M register would be the two inputs that the ALU computes if a function on, in this case, and if then generates output. Its control bits such as ZX, NX, NY, ZY, FO, NO indicates which function is computed on the two inputs, that is X and Y, to produce the output. The outputs, we have the out and two control bits, namely ZR and NG, which determines the properties of the results. The code next of two OR gates and one AND gate sets the ALU output in order to successfully write on the data memory. Now we have come to the output parts. The in next code, the load bit of the CPU is determined by the jump bits and the ALU outputs. These further lines of the code determines the jump condition and checks the ALU output. If the instruction is C instruction and conditions are met, then the PC is loaded with the value. That asks the CPU to jump to the specified value. If the PC is not loaded, then the PC is incremented. Now, let's come to the pros and cons of the hack CPU design. The pros are, first one is memory organization. That is, the hack memory is divided into two separate sections, one for instruction and one for data. This separation makes it easier to keep track of where instructions and data are stored. Second pros is single cycle design, which means the hack CPU is a single cycle design, that is, it fetch, decodes and executes an instruction in one clock cycle, which makes it very fast. Third pros will be modularity. It is because the hack CPU is divided into distinct functional units such as ALU, memory, and input output devices, making it easier to understand how the different parts of a computer work together. Now, the hack CPU has some cons. First one is limited functionality. It is because the hack CPU has a very limited set of features, which makes it not very useful for real world applications. Second is simplicity. It is because some people argue that hack CPU is too simple and does not accurately reflect the complexity of real world. Overall, the hack CPU is simpler, modular, and flexible design, making it a valuable tool for learning about computer architecture. However, it does not reflect the the real world computer complexity. Now, I will be telling the pros and cons of the code. One of the advantages of the code is that the control flow is apparent. That is, anyone can reasonably understand how the CPU progresses, managing the program counter, instruction execution, and conditional branching. The control signal and logic gates involved in determining the next state or action are apparent and can be traced through the code. Now, one of the areas which can have potential improvement is the use of more comments. Uh, the code already has some comments, but adding more comments to the chip APIs can enhance the readability. As you can see, I have added in between uh, the codes. Also, some internal pins like AINS and AM out can have more descriptive names. This completes the pros and cons of the code. Thank you.